We're going to talk about the superposition of waves. Imagine any time you have any given wave that is traveling in the x direction. At the very same moment and at the very same place, there is another wave traveling, let's suppose, at the same direction as well. At the very end, what you will see, or what is going to be perceived by an observer, is the addition of these two waves. This addition is, for instance, what you see of wave 1 plus what is perceived of wave 2. That will be the total wave you will actually perceive. Life is not a sinusoidal wave. Actually, life is a series of sinusoidal waves added together, doing a wave superposition. Let's suppose we have two waves that have the same characteristics, the same amplitude, the same constant k, which is the wave constant, or the same wavelength, and the same omega, which is, for instance, the same frequency. But the only difference between both of them is that one has a phase and the other does not have a phase. It will mean one is dephased against the other. Then the sum of both of them, which will be the actual wave perceived, is going to be equal to A, for instance the amplitude, times the sine of kx minus omega t plus the sine of kx minus omega t plus phi. Using a trigonometric expression which states that the sum of two sines can be actually 2 times the cosine of a minus b over 2 times the sine of a plus b over 2, we can actually state that the sum of these two sines is going to be equal to a resulting wave of 2a cosine of phi halves sine of kx minus omega t plus half the phi. Try to do this at home. The resulting wave will be a wave which has a new amplitude given as 2a cosine of phi half. This is the new amplitude, and the same characteristics, but it's going to be dephased in phi halves against the original one, right? This is important because if this is the new amplitude, it could happen that the amplitude is constructive when the cosine of phi half is equal to 1 or minus 1. That happens when, for instance, phi is multiples of p, pair multiples of p, right? This is n being a pair. It could be that, for instance, 2p over 2 will give me p. But if phi equals, for instance, mp when n is an odd number, for instance, cosine of p halves, then this will be a destructive interference. There will be no amplitude at all. You can build up a wave, or you can destroy a wave by dephasing or sending another wave with the phase, which is, for instance, mp being n a pair. You can construct the wave, or you can destroy the wave, sending another wave which has the same characteristics but is dephased in mp, or an odd number of p, right? Now imagine two waves that have the same characteristics, but the only situation is that one is traveling towards the right and the other one is traveling towards the left. What happens then? If we follow the same procedure as adding them, what we will have is that the resulting wave, you can do this at home, is going to be 2a sine of kx times cosine of omega t. When can this happen? You can actually put a wave and the reflection will have the same characteristics, just traveling towards the other direction. You have generated a wave where certain expression depends only on x, certain expression only depends on t, and not in both of them. This is called an standing waves. You can see a video of this in YouTube or whatever. The standing waves will have this kind of figure. For instance, if this is a string, you will see that you can have two nodes, two nodes, and one antinode. It could also happen that this has 1, 2, 3 nodes or 2 antinodes. Or it could happen that it could have 4 nodes and 1, 2, 3 antinodes. Then, if this is the length of the chord or of the string, in the first example you will see that the length of the string is equal to half the wavelength. In the second situation you will see that the wavelength is the length of the string. In the third it's going to be 3 halves of the wavelength, and so on and so forth, such that the end length could be actually n lambda over 2. These are called the harmonics, being, for instance, if n equals 1, it's going to be a fundamental wave. The second harmonic is going to be when n equals 2, and so on and so forth. Now, given the situation that frequency is going to be equal, well, let's state, for instance, velocity of the wave equals lambda times frequency, then the frequency is going to be equal to velocity over lambda. Now, in the first case, or if we generalize, the end frequency is going to be equal to n over 2L, which is the inverse of lambda, right? From here, from this equation, times the velocity. If we have a string, this is going to be n over 2L times the square root of the tension over the linear density. This is going to be the n harmonic, or the n frequency generated by a string which has a tension, has a linear density, and has a length. Try to figure out what happens if we vary the parameters and how we can actually vary them in life.